So, for this problem, we're going to differentiate a series of simple functions with respect to x using implicit differentiation. So for the first one, we're going to differentiate y. So in order to do that then, first of all, we differentiate it with respect to the variable itself. So we're going to do dy by dy. And when we differentiate y with respect to y, we end up with 1. Well, in order to then differentiate it with respect to x to make the dy's cancel, we need to multiply that by dy by dx, which is why we end up with the notation of differentiating y with respect to x as dy by dx. Well, extending that a little bit further, if we differentiate 4y with respect to y, we are just left with 4. But again, we need to multiply that by dy by dx. So we end up with 4 dy by dx. Extend that a little bit further again. If we have a y cubed, we can differentiate that with respect to y. So we bring the power to the front and multiply it, 3. We leave the function itself, y. We drop the power by 1, so 3 becomes 2. But we can't forget we need to multiply that by the differential dy by dx. So we end up with 3y squared times dy by dx. So then we have ourselves a trigonometric function, similar idea again. So we've got sine 2y. We need to differentiate this with respect to y. So the differential of sine 2y with respect to y becomes 2 cos 2y. But we can't forget we need to multiply that by dy by dx. So for e, we have cos cubed t. Well, let's rewrite that a little bit, as we often see. Let's rewrite that as cos t all cubed, and let's differentiate this. So we need to use the chain rule, and we're going to differentiate it with respect to t first. So the 3 comes to the front as a multiplier. You have cos t, so you leave the function as it is, drop the power by 1, so it becomes a squared, and you multiply it by the differential of this function, and the differential of cos t is minus sine t, but we can't forget as well, we still need to multiply this by dt by dx. That's in order to get rid of, in this case, the dt's. So if we simplify that a little bit then, just to make it a little bit nicer, minus 3 sine t cos squared t times dt by dx. Now, we've got 1 over root t. Well, we don't like it in that form, so let's convert it into index notation. So we can rewrite that as 2t to the minus a half. Fine. And then we can apply the same rules again. So we're going to differentiate this with respect to t. Bring the power to the front as a multiplier, 2 times minus a half minus 1. Leave the function as it is t, drop the power by 1, so it becomes minus 3 over 2. But we can't forget, we then need to multiply that by dt by dx. Okay, again to get rid of the dt's, so we're actually differentiating it with respect to x. Well, a couple of extra ones, the natural logarithm next. So if we've got the natural logarithm, let's go back to y as our variable. So we differentiate this with respect to y, which gets us 1 over y, which we then need to still multiply by dy by dx to get rid of those dy's. So we're just differentiating with respect to x, really. And then for e to the 3y, when we differentiate that with respect to y, you end up with 3e to the 3y, and again, to get rid of those dy's, we are multiplying that by dy by dx. So that's a series of simple differentials using implicit differentiation, where we're differentiating with respect to x.